The other major topic in section 3.4 is amortization. Okay, now that's a funny word, but basically what it means is you are paying off a debt. Okay, so let's go ahead and read these first couple of bullet points. Okay, it says, suppose that you took out a loan, okay, either a home mortgage, a car loan, student loan, something like that, and you wanted to pay off the debt in a fixed number of payments with the bank charging interest on the unpaid balance. A debt is amortized or killed off if it is repaid by a regular sequence of payments. Okay, so for example, maybe you've had a car loan in the past. Okay, so when you purchase the car, you buy it for a certain price, but if you finance the car, when you pay it back, you don't pay just the purchase price. You pay the purchase price plus any interest that accrues on the unpaid balance. Okay, so with amortization, it is basically a formula that's going to help you calculate your payment. Okay, whether it's a monthly payment, for example, that monthly payment that you make over the life of the loan is going to help you pay off the purchase price of whatever you've bought, plus any interest that has accrued on the unpaid balance. Okay, so in the second bullet point, how do we calculate the correct payments to amortize a debt? Okay, and again, when we're saying debt, we're talking about purchase price plus all the interest. Okay, the payments form an annuity with present value PV equal to the debt D. Okay, so to find the payment P to amortize your debt, we are going to replace PV with D in the present value of an annuity formula and solve for P. Okay, so basically what this is saying, okay, when you're paying off a debt, like for example, your car loan, okay, you might be paying, I don't know, $300 a month, okay, for 60 months. Okay, so you're making these regular payments. So amortization does involve an annuity, okay, and one step further, what this statement is saying, okay, the present value, if you go out and buy a car right now and you make a car loan right now, okay, the present value of that annuity is equal to your debt. Okay, so what is done to come up with the amortization formula? Okay, and what that formula tells you, like I said, is going to be the monthly payment or the quarterly payment or whatever, the periodic payment that you have to make in order to kill off your debt, which is the purchase price plus the interest. Okay, the way you come up with this formula is to take the formula for the present value of an annuity, you replace the present value with the debt, okay, and then you solve for P, the payment, okay. So let me show you how this is done, okay. This is the present value of an annuity formula, if you remember. Okay, oops, I'm getting ahead of myself and putting a D, okay. So it was present value is equal to P times all this stuff, if you remember. All right, so what you would do to get the amortization formula, okay, like I said, when you're paying something off, you're making regular payments, so it is an annuity, okay, but the present value is equal to the debt. Like if you go out and buy something right now, okay, the present value is equal to the debt, the purchase price, okay. So we're going to make that replacement. We replace PV with D. And then all we need to do now is solve for P, okay? So we need to get P by itself, okay? P is multiplied by all this stuff, okay? So it's going to take a little bit of work here, okay? But what we're going to do, okay, is we're going to first try to get rid of this fraction one step at a time here to get P by itself, okay? So on this right side, we are dividing by R over M, okay? So to undo that, we're going to multiply both sides by R over M. Okay, so then you will have 1 in the top and then 1 in the bottom, and they will end up canceling. Okay, so in your next step, you're going to have that D times R over M is equal to P times 1 minus 1 plus R over M to the negative MT. Okay. All right. And then in your next step, okay, you're very close to isolating P. Okay. This stuff, like you would plug in your R and your M and your T, okay, that would give you just a number. So you have P times all of this stuff. So if you want P by itself, all you have to do is divide both sides by this quantity in parentheses, okay? So you're going to get that the left side is D times R over M, okay? We're going to have to divide both sides by this quantity, okay? So this thing, okay? And on the right side, okay, you know you're already going to have P times all of this stuff. Okay, and you would have to divide it off to get P by itself. Okay. All right, so then on the right side, okay, this would cancel with this. Okay, it's going to leave you with P. Okay, and then this is basically your formula. Okay, so if you look down here in the box, okay, I've got the formula. So in this box, I've got the amortization formula. It's very close to what we have, okay? Basically, the D is pulled out to the side, okay? And then you've got this other stuff that I've got written down, okay? So basically, what you can do here, algebraically, what you can do, since you've got D times R over M, that D can go out front, okay? And then, you know, you can have just R over M in the top, okay? Rules of algebra say you can do that, okay? So this is kind of where your amortization formula comes from. Okay, so now it's exactly what we have right here. Okay, I know this is kind of boring and like, why are you doing this? You do not need to know how to derive this formula at all. I do want you to know though that the amortization formula and the present value of an annuity formula, they are the same formula. Okay, so one more time, the present value of an annuity formula and the amortization formula are the same thing. Okay, the only difference is that PV and D, they are equivalent. Okay, so one formula is going to have the PV, the other formula is going to have the D. Okay, the other difference is that for present value of an annuity, that formula is solved for PV, which is D. Okay, in the amortization formula, the formula is solved for P. Okay, but they are equivalent formulas, which means you can use them interchangeably. Okay, again, what you have to remember is that the present value and the debt are equivalent. Okay, amortization formula, like I said, you're always going to use it in the case of paying off a debt. Okay, it is the last formula on your formula sheet. Okay, so here it is. Okay, it's under the amortization. Okay, it is probably a very easy formula to recognize of when to use it because it's got D, and D stands for debt. Okay, so I'm going to go ahead and write on here. Okay, here's your amortization formula, and you want to use this guy when you are paying off a debt. Okay, so here's the formula one more time, and then again, here's the meaning of all the variables. D is the debt or the purchase price of whatever you have bought. Okay, P is going to be the payment that you have to make every month or every quarter or however often to pay off your debt. Okay, R is the interest rate. M is the number of compoundings per year, which also coincides with how often you're making payments. Okay, T is going to be the time in years over which you have to pay off the debt. Okay, And now we're going to move on and start getting some practice with this formula.